let us study about state of stress at a point in 3D. See, this is a 3D body, okay, 3D element. See here, this is our x-axis, this is our x-axis, this is our y-axis, and this is our z-axis. And the stresses, the normal stress in these directions are represented as sigma x, sigma y, and sigma z. Okay, and now let us learn about the representation of shear stress. Let us take a look at 2zx. See, this is our 2zx. What does that 2zx represent? The second sign x represents the direction in which it is acting, direction in which shear is acting. Shear is acting. And what does the first sign z represent? Z represent that it is acting on a plane whose perpendicular is in z direction. The z represent that it is acting shear toe is acting in a plane whose perpendicular is in z direction. So it indirectly represents the plane in which it is acting. Similarly, all other values 2yx, 2xy, etc. Okay, so we have our stress tensor sigma ij represented as sigma xx, 2xy, 2xz, 2yx, sigma yy, 2yz, 2zx, 2zy, sigma zz. We will learn about complementary stresses. Now let us check. See, there are 9 components here. 9 components here. We will now learn about complementary stresses. See in another lecture. So before that, just remember this: 2xy is equal to 2yx, and 2 based on complementary stresses. Okay, and 2xz is equal to 2zx, and 2yz is equal to 2zy. So these are like same, means that here this and this are same, this and this are same, and this and this are same. So we will have 1 2 3 4 5 6 independent components. 6 independent components. Okay, so that is it. We have a 3D element. This is a stress at a point in 3D plane. So we will have 2zx value. The representation we have learned, x represent the direction and z represent it is acting in a plane whose perpendicular is in z direction, and we have studied about the representation of stress tensor. In this there are 9 components, of which 3 are equal to the other 3, so we have 6 independent components of this. Okay, if you do like this video, do share, subscribe, and press the bell icon. Okay, thank you.